It's time 3 bullet points of objectives. Let's get busy. Reading chapter 19 would be a good idea. Sections 4 and 5 will get you to the information I'm presenting here. So, titrations. Titration is a lab. It's a lab technique, and we use it to find out what the concentration of an acid is or what the concentration of a base is when we don't know it. So we're going to need a mathematical formula to calculate the molarity of a missing acid or base. It should look pretty familiar, like M1V1 equals M2V2. The only change in this is that the A stands for acid, okay? A, acid, B, base, and then the X's. So there's an X here and an X here because the number of H's from the acid and the number of OH's from the base have to come together to make H2O in this kind of reaction. So we use this technique using a buret. A buret is this way to transfer one of the two solutions, and then we put another solution underneath. Okay, one of these two things has to be unknown, meaning we know it's an acid or a base, we just don't know its concentration. So we're looking for molarity. What's the molarity in this? We don't know, but we do know the concentration of the base, so we know that. So we're using to find molarity. This buret reads to 0.00 milliliters, so it's pretty accurate. We use an indicator down here so that would change its colors when the number of moles of H plus equals the number of moles of OH minus, and that's the neutralization part. Okay. So what does neutralization mean? Well, a neutralization is a chemical reaction, and in a neutralization, the acid gets neutralized and the base gets neutralized, so it's no longer a base, and you get water. Okay. So the H's from the acid and the OH's from the base are going to make H2O. And that means that the metal part of the base is going to come together with the non-metal part of the acid. And then from the periodic table, Na is +1, periodic table F is -1, so the chemical formula is NaF. And we don't need any coefficients because we got 1H, 2H's, 2H's, 1O, 1O, 1. So you got to get the correct chemical formula. Is the product acid or base? Nope, neither. Okay, so we have water is one of the products, and salt, meaning an ionic compound. So here's some examples of the actual chemical reaction that could go on when you do a titration. So here's the neutralization reactions. So here's our acid, here's our base. So we know they're going to neutralize each other. What's a neutral? Water, H2O. And so then we have the K, which is a +1, and the NO3 is a -1, so we get KNO3. All right, here we go again. We have an acid and a base. And so we know they're going to come together to make water. Water is always a product. And then we have an iron, which is a +2, and a nitrite, which is a -1. So we need a FeNO2 to cancel the charge. And now we need to balance the equation. So we need 2 of these. So that gives us 2 NO2s. That gives us 2, 3, 4 H's. So we need 4 H's. And we have 2 O's, right? So here's what you should remember, that the acid and the base come together to make a salt, which you have to cancel the charge, and then water is H2O. You might have to use coefficients when you're done writing the formulas. All right. So titration is a technique, and neutralization is a reaction. And so now we're going to use the formula. So we have 54 milliliters of 0.1 molar sodium hydroxide neutralizing 125 milliliters of HCl. So what's the concentration of the HCl? So here's our formula, XMABA equals XMBBB. All right, so the A step's about the acid. Ma is the molarity of an acid. Concentration of HCl, that's what we're looking for. Volume of acid. Well, let's see, how much acid? 125 milliliters, so 0.125 liters. All right, then this X equals the H pluses in the acid. So let's look at the acid. It's HCl. So we look at how many H's there are. There's 1 because it's HCl. Okay. All right. MB is the molarity of the base. So we look, okay, 0.1 molar NaOH. The volume of the base is 54 milliliters, so 0.054 liters. And the X on this side is the number of OH minuses because it's the base, equals 1. Why? Because it's NaOH. Right? And so there's 1 of them in the compound, 1 of them. All right, so then we plug it all in, and we get 1 times the molarity of the acid is what we're looking for. The volume of the acid, 0.125 liters, equals 1 for X. Molarity of the base is 0.1 molar. The volume of the base is 0.054 liters. Okay, if we solve for X, we get 1 times 0.1 molar times 0.054 liters divided by 1.125 liters. Look, liters cancel out. We're left with a capital N. And the calculation will give us 0.0432 molar. So that's the concentration of HCl. All right, let's do another one. All right, so we have 50 milliliters of KOH and 125 milliliters of H2SO4. We want to know what's the concentration of H2SO4. So our MA is what we're looking for. Volume of the acid is 0.125 milliliters. And X equals H plus for acid. And this time it's 2. Why H2SO4? That's that. And there's 2 of them. 2 of them. Okay. Molarity of the base is 0.5 molar KOH. Volume of the base is 0.050 liters. And the number of X's for this side is the number of hydroxide ions in the formula. So it's KOH, and so it's 1 because KOH, OH, and there's 1 of them. So then we just plug it in. 2 H pluses times the X times the 0.125 molar. Liters. Got me. Okay. 1 hydroxide times 0.5 molar times 0.050 liters. Okay, this time we're solving for this X. So we can take 1 times 0.5 molar times 0.050 liters divided by 2 times 0.125 liters. Oh, look, liters cancel out. You're left with molarity equals molar equals 0.1 molar H2SO. All right, so remember this formula, XMAVA equals XMBVB, and the X's are H plus for acid and OH minus for base, and it's however many there are. Okay, vocab word anhydride means without water. So we're going to be looking at compounds that don't have water in them, they don't have H plus, and they don't have OH minus. So they're called anhydrides because they don't actually turn into acids or bases until you put them in water. Okay, so acids and bases are always dissolved in water. If it's not dissolved in water, it's not an acid or base. So there are some compounds that when they're not in water, they're not an acid or base, so you put them in. So they're called anhydrides. So metal oxides are compounds of metals. So any metal oxide, oxygen, makes bases when you put them into water. So they're called base anhydrides. So one example of a base anhydride would be Mg. Another example of a base anhydride would be Na2O. So you see the oxide, and the metal. Now when you put it into water, so when put in water, Na2O turns into NaOH. Oops, sorry. You know what? We'll do this in class, but Na2O, when you put it into water, plus water, turns into NaOH. All right, so we get 2 of those. All right, 1, 2, 1, 2, 1, 2. All right, so Na2O, when you put it into water, it turns into NaOH. So these are called base anhydrides because they're metal oxides when they're not, so they're solids. They're usually solids. And when you put them into water, they turn the water basic. Okay? Non-metal oxides, so that's this side of the periodic table, are called, well, you make acids when you put them in water, so they're called acid anhydrides. Okay? So let's do some examples. Example, CO2. Okay? Oxide, non-metal, so it's called an acid anhydride. Okay, here's why. When you put CO2 into water, you're going to get H2CO3, acid. All right. So acid anhydride turns into acid when you put it in water. So another example is NO2. Another example is SO2. Okay. So all of those are called nonmetal oxides, and they are called acid anhydrides. Okay. So you might be wondering why we're talking about this. Well, all of this pollution, okay, NO2, CO2, all of this stuff is put into the atmosphere. And when it hits the water, okay, so plus H2O in the upper atmosphere, then it turns into acid. Acid. So acid anhydrides turn into acid when they mix with water in the atmosphere. There we go. Ugh. Oh. So what kind of effects can acid rain have? Well, here you see some results, and this is just being silly, all right? So let's review. A titration, we learned about titration. It's a technique that uses an instrument called a buret, and it's usually to find unknown concentration. Neutralization reaction is a reaction that uses chemistry. When you take an acid plus a base, you neutralize it, and you make salt and water. Okay? Titration uses the mathematical formula, and we put our A's and our B's in there, and these are our H pluses, and these are our OH minuses. An anhydride is something without water. An acid anhydride comes from a non-metal oxide, and a base anhydride comes from a metal oxide. That's it, friends. Acids and bases. The notes are done, but guess what we'll do in class? You guys practiced, you're right. Okay, so read the chapter 19, sections 4 and 5. Also, be able to do these things. Okay, go back through and see if you can answer these questions using your notes. All right, peace out.